Ms. Courtney, can you pick up the understanding checks? While you got time? Before she gets there. Who got here a little late? Mitria? You got here 20 minutes late, I think, right? Let's do this. Enrichment. Who do you have for enrichment?
Yeah, named on it.
If anyone who I'm writing, if they got here late, note that, or put that on the top so that we can easily access. I think you got here about 10 minutes late too, didn't you? Demetria, you were actually 15 minutes late, weren't you? Something like that. I think you were. I think Kenyon was 20. Or were you 15 minutes late? Okay, so you were 15. JK. I was right originally. Who do you have for enrichment? Okay. Lightfoot. Anyone else? Tyler? So you're about 10 minutes late. That's not right. Who do you have for enrichment? Was anyone else tardy? Not tardy.
Are these only ones that need to go on top?
Yeah. And then Demetrius. Yeah. All right. I need you to go ahead and get out the equations for linear and exponential functions. We're going to take about 20 minutes with that. That is on the back of one of the tasks or practice problems we did yesterday. Gerald, I need you to log out so that you can participate in today's lesson. Huh? What?
You said do again.
Log out so you can participate.
No, come on.
I'm about to give it to you because you haven't been here for almost a week.
Are you talking about the three graphs? Miss Kim?
Nope. Talking about this sheet. It's the other one, the linear and exponential one.
Oh, yeah, right here.
Everybody see it? Linear and exponential, this sheet. Does anyone else need a copy of this because they weren't here the last couple of days? Huh? Your book? Coach's class? You want to go grab it real quick? Does it have these sheets in there? Miss Courtney, here's this one. Okay. I do want to pause and I want to point out something. Really quickly, look at the other side of the linear and exponential function side. Linear and exponential, look at the other side. They're not the exact same equations, but those problems look familiar? Right?
Yeah.
Resources I give you, you need to study for understanding checks. I already saw quite a few students who, one, didn't write points for the y-intercept or the x-intercept.
Dang, I messed up.
We always got to write those points. We got to remember when we talk about R1, R2, and that H for the x-intercepts and the vertex, we need the opposite. We need to make sure we study. Now, I'm going ahead and saying this, and I'll give you back your understanding checks tomorrow, but I do want to remind you, whatever you score on this understanding check, that's not the final grade, right? Why not?
Because you got a test.
We still got a test. We got some stuff to learn before Monday. But if you learn the content better, then you will earn a higher grade, okay? So I care about when you, or I care that you learn it, not necessarily when you learn it. And looking at the linear and exponential understanding checks, we got some stuff to learn there, right? Writing those equations. That's why we're taking some practice on this today, working within our small groups. But you still need to study outside of class time. You got to know those equations. Otherwise, it's hard to work through this. I will have your graphic organizers back if you turned those in yesterday or 2 days ago to you tomorrow. I'll have these understanding checks back to you tomorrow. But we gotta get to work. After that, we're gonna work on 6.6, how does it grow? So go ahead and get out that 6.6, how does it grow? There's 2 pages, you worked on it last Wednesday when I was out. And then you turned it in, just when the sub was here.
Yeah.
So I need to show you all what it looks like quickly. Looks like this.
Oh, that.
6.6, how does it grow? You weren't here last Wednesday? I'll give it to you once we get started. Let me get started. But let me know in a second if you haven't done this. But
Miss Kim, we didn't turn it in.
you did turn it in, I gave it back to you. Or I should have given it back to you. Miss Courtney, do you have any 6.6s back there because they didn't get it?
I don't think so.
I didn't think so either.
You need me to run downstairs real quick?
No, I have extra copies here, but we'll get there.
Okay.
Okay. So, linear and exponential functions. First off, before you can ever write an equation, what do you need to do?
About what it is?
When you say figure out what it is, what do we mean by that?
Well, no way time equation it is.
But remember, one, we're not dealing with quadratics right now, but to know what equation to use, you need to know the type of function, right? And that's what you're hinting at, but we gotta be clear with our language, right? Looking for clear, consistent, and convincing evidence of our understanding. And so you gotta be able to identify the type of function. And you gotta know how to justify that. And then after that, when we talk about linear and exponential, yes, there are actually multiple equations, but we've only studied one for each of those. You gotta know the equations for a linear or an exponential function, and then the 3 different quadratics. We gotta study it and get better at it. And so we're gonna work with our small groups to do that a little bit. Here is my recommendation to make sure we're as efficient as possible. You have 4 tables. I would, with the time that you have started, identify one linear equation and identify one exponential equation, or linear and exponential function, and write the equations for them off the table. After that, I would do one linear function and one exponential function from the graph so that you get practice with both of those. And then, if I have time, I'd go back and do extras. But remember, I'm looking for active collaboration. So, should Denasia be working on number 13 and Kyle working on number 15? No. That's not active collaboration. We should be working together, helping each other grow and get better. You got people to talk with. Say again.
Things that with this sheet.
That's what we're going to do next.
Oh, what are we doing now?
This is on the back. So we worked on this sheet yesterday.
Oh.
This is on the back side of it. And I'll write it on the board what I would recommend, but do we understand what I'm asking you to do to get started? Let's get to work. Let's learn those linear and exponential functions a little bit better. So one linear and exponential.
Yeah.
No, I'm telling you, I think you should.
You know, like, when you first started doing it, you gotta do them from that, you gotta start on that. You gotta do that one on each side. Figure out what you-
Anthony, be careful with your language. We're not solving equations. Right? We're not
I
trying to
said
find.
solve.
We're not trying to figure out what makes an equation true. We're trying to write the equation. So you need to identify the function, and from tables, what do we need to do that? Well, if you're looking at a table, what's going to tell you what type of function it is?
The numbers, the big, or
So,
what it's been added on.
so that's the rate of, correct, the rate of change. I mean, it would help you prepare for understanding checks, wouldn't it? Kelsey did ask a good question. Do you need to justify on this practice? I mean, technically no, but wouldn't it help you prepare for understanding checks well? I would use calculators to help check and make sure I'm adding, subtracting, multiplying, dividing correctly, things like that. Thank you.
So negative, oh,
Oh, what do I got here? On the Wi-Fi.
Hey, I remember there was one thing that you did, was that I pretty much had it right, but I was missing one part, and I put conquer out of the rate of change, and he was like, of what?
2 to 10
Finish it all like that.
Okay, so one thing I do want to caution you and remind you, just in case it's not +1, don't forget you need a change in y divided by the change in x. So if this was like a +2, the constant additive rate of change would not be -7, it'd be -7 divided by 2, right? Because remember, the constant additive rate of change is also called a what? It's an S word. Or the S word, the linear function. Yeah, right? So like, you need to remember that the constant additive rate of change is the slope. So if it's not +1, you gotta keep that in mind. And that's why I point out, like, by what, because I need to see that you understand that it's changing 1 divided by 2.
Oh.
Right. Now, -7 divided by 1 is -7, but if it wasn't a 1, you need to acknowledge that. Correct. Correct, exactly. It'd be completely different.
Um,
Let's get